Good morning and good evening, everybody, as per the time zone. Women who code data science community is little close to my heart, as I was involved with the community during my career break. So the topic for today's discussion is going to be design thinking in artificial intelligence. I am Kirthikka Devi Venkataram. I'm employed with Bosch Engineering and Business Solutions as an architect. As coined by Clayton Mitchell and McDonald, disruptive innovation, a word coined by them, is the era that we live in. So, disruptive innovation has not only limited us to have in terms of technology or in terms of business model as such, it is one way how we see the world in this era. AI, artificial intelligence, is going to be one key enabling technology, a key enabler or in technology front that is going to enable disruptive innovation. Okay. It is not only going to be a key enabler, it is also going to redefine the complete framework at different levels of the firm that AI is going to operate. The AI driven operating model is going to generate revenues and it is going to show us growth, creating networking effect between the business and the user, which is going to be enormous. The networking effect that it is going to create is going to be enormous. So now we understand how important artificial intelligence is and why do we need design thinking is what we are going to understand in this lightning talk. Let's get into the topic for today. So the agenda of the topic is going to be understanding design thinking. What do you mean by design thinking? The mindset or the paradigm, understanding it from the process steps, and the big picture, the AI landscape, the different major players involved in creating AI products, and how design thinking is going to help us out in creating a user or human centric based AI product. It was rightly coined in Harvard Business Review, like the new algorithm suffers from cold start, which means there is inadequacy of data that is being projected. When we say something like inadequacy of data, there is going to be constraint in the resources. So how are we going to indulge ourselves in creating AI product? So there are a lot of other things which we are also going to be considering when creating an AI product. So when Uber looked at appointing a new CEO, they wanted someone from a digital world. This helps us to understand what is the importance of AI in different domains. I just want to coin here one more important point about the Digital Life Design 2020 conference. So there was a conversation between Gary Kasparov, the world's youngest chess champion, and Michel Petrosyan, the CTO of Avast. They had a very great conversation, an intuitive conversation about what does AI add to our lives. During the conversation, they were uh, considering the fact like jobs are not going to be disappearing, but instead it is going to evolve. The repetitive job nature would be getting deleted and people will become more creative. So this, the future of human race is going to be more creative. Now we understand what is the importance of design thinking and how it is going to impact us in creating AI product. So considering the different uh, environment, like the business environment, which needs the value that we need to create out of it, the technology environment, which is constrained with the with the technology, with the technical constraint that is involved in, and the other one is the user, the needs of the user, the insights that we get from the users, and the sweet point of all the intersection of it is going to be the innovative product. So the environment the human machine interaction, and the outcome. These three are the major paradigm involved in having an AI based product. So let's consider what do you mean by the environment? As we understand, the business value is highly important, and the technological boundary with the user needs are one of the input that we need to understand before getting into any product design. Now, especially into AI product, how do we approach this particular environment? How do we get this particular environment into our approach? AI has different levels by its intelligence, with the human decision making process and with the faster analysis of the machine. So the overlapping of the human decision making process and the machine based faster analysis approach gives us a way to decide how much amount of human and how much amount of machine is going to be involved, and what is the level of interaction that both of them would be having together to create us a product, and the outcome of it is going to be an AI product. We know there are different levels of AI intelligence, like reactive machines, limited memory, theory of minds, and self-awareness based AI. So how the level of human and the machine interaction decides us the type of AI product that we are going to derive out. That is what is depicted over here. So this gives us an understanding of the intelligence or the self-awareness based AI product, the maturity of the AI product based on different levels like self-awareness, theory of minds, or limited memory based is decided based on the maturity of the AI product that we are going to deliver. This is one famous two questionaries which has been framed and which has been published in MIT Campus News, understanding the needs of advanced computing in different domains. They were querying to people to understand the importance of the importance of advanced computing that it is going to create in the field of arts, humanities, and sciences. So this makes us to understand AI is not going to be involved only in engineering, but it also is going to dwell into different domains. So these two are the questions that they have framed. What domain knowledge, perspective, methods from your field should be integrated into the new MIT Shishman College of Computing, and why? What are some of the meaningful opportunities that advanced computing makes possible in your field? These two questions gives us to understand how important we are, or how the era is driving us to get into a diverging and converging approach in each process step that is involved in creating any type of product. When I mean like diverging and converging, the design thinking helps us to understand, or the design thinking, the core mindset of design thinking is like we diverge and then converge in each process step, so that we pick up or filter out very new or innovative ideas, and then we implement it into a meaningful outcome. Okay. This is something like how we need to create or co-create. Co-create, I mean like we need to associate ourselves creating AI product with design thinking mindset. This is one famous playbook that I would suggest you all to have a look into. So the design thinking playbook which is available. This design thinking mindset has an approach of series of steps that we need to understand. So it is like the first step would be to understand and observe the customers, getting the explicit and implicit needs of the customers, finding their insights. There are different tools and techniques which is involved in each of the process steps, which we are not going to discuss currently, but we would be concentrating only on the process steps in this particular talk. So the first step is understanding their needs, understanding their implicit and explicit needs, what a customer wants, sitting into their shoes and making to derive out their problems, as well as to create, to potentially evolve new ideas and thoughts, so that that would be helpful for them. The understanding and the observation step is followed by defining the problem statement. So defining is something like You address the potential or critical assumptions. You need to review each of the critical assumptions that is involved in defining the statement. The third step would be to go for ideation. So, brainstorming is one way of ideating. We know there are a lot of other ways as well. This is one way where we need to ideate, where we need to create new thoughts that will help us out to move to the next step called prototyping. So, prototyping and testing is a cyclic process. It is an iterative, repetitive process which is involved to get us a more rigid or a more scalable product on a whole. So, this is the basic of design thinking mindset, or how we need to understand, how we need to have our complete mindset change when we are creating a product. Now, we are going to understand how do we co create that, the design thinking mindset, on AI product development. Generally, in any machine learning or ML DL based approach, there is an exponential learning which is happening where we have the set of resources which we would define. It might or might not be available to us at the initial state, and then we try to implement it and we set some KPIs for measurement. This goes in a cycle uh, this goes in a cycle altogether, and the cycle is a never-ending process till we achieve our goal or the outcome which we desire for. This exponential learning could be optimized in a way when we understand or when we indulge design thinking mindset into our approach. Let's see how this is going to help us out. The design thinking paradigm is like focusing mostly on the customer's outcome, having a non-stop innovative mindset, and having a diversified, empowered team. When I say it as diversified, empowered team, diversified means teams having from different uh, teams in the sense design, development, and research team, having an empowerment, which means an authority of decision which they would hold. So when we have such a set of team altogether, we create very new products and we have successful outcome. This is one step which we need to consider while having a product design. Apart from this, we do have other resources, the software, hardware resources, the other environmental constraints, and different technical details which we need to take care. Design thinking mindset helps us to understand all this upfront. Like we need to understand this beforehand, where before we get into the implementation step. That is the sweetness of having a design thinking mindset when we are going to create a product. So this is obviously helpful in creating AI products as well when we see the overlap or the approach that design thinking is going to have. This is what is explained over here. So this particular mindset, the design thinking mindset, how it will get overlapped with the exponential learning approach. This picture is going to be your reference for understanding or the AI landscape, the big picture of AI landscape where the major players involved in creating AI products are associated with. Artificial intelligence also has an amount of data processing, an amount of implementation approach with AI, with ML or deep learning approach, and the different types of data, which is going to be private, public, social, or open data, and the type of data flow in each of the steps, the pipeline that we are going to follow, the stream of the data flow, and how that data is going to learn about to create something based on uh, expert based task or a perception or how we call it as a mundane based task, and how data science helps us out in deriving those tasks. This picture this is an intuitive pictorial representation which gives us to understand the major stakeholders that is involved in creating an AI product. Here we are also considering the four V's in the big data, four V's, which means the volume, velocity, variety, and the veracity, which means the credibility of the data that we have in hand. So now we'll be getting to the AI product design case. There was one interesting project that I was involved in where I need to understand creating an AI based product doing a design thinking approach. So, how it will go about? This is like the first step as we understand creating or understanding the user, which is the creating an empathy map, which is the output of understanding the users. We gather insights and needs from the user and we create an empathy map. Empathy map will give you the gain and pain points that is involved with the user. Then we define the problem statement, the point of view statement, which is going to be a detailed statement of giving our problem. We obviously know a half-filled a half-filled problem statement is a complete, a complete problem statement is a half-filled solution. Then we get into the ideation process where we gather experts in our group from different domains and we brainstorm for different ideas involved in. Then we create a prototype. Like there are different ways that we create a prototype currently. Like Wizard of OS is an old methodology in creating prototype. Right now we have a lot of platforms that we can create prototypes as well. And we test our prototype with different techniques like AI/ML validation techniques or A/B testing, generally speaking. So these are the second point, the second line describes the way or the approach or one of the tool that we use in each of the design thinking process step. There are many other tools and techniques which are involved. I just wanted to highlight you few of the tools and techniques which is involved over here. Let's take an interesting case study. I was involved in creating a product. I was involved in understanding the product, which is called personal food or dish recommender system. So visualizing it as a product on a whole, initially there was involvement in prototyping and testing of that particular product. So this obviously involves understanding the complete or visualizing the complete product, like how it would look like. So when this was considered, I just thought of applying my design thinking concept into it. Visualize that as a complete product and understand the resources that are involved in, derive out from the resources what would be the applicable algorithm. So this is the converging and the diverging and then converging step. We sort out different algorithms which are available and different process steps that could be involved in deriving out a new algorithm or use an existing algorithm way. So this approach helps us in converging our ideas from the divergent approach which is available, and then we prototype it, and then we test our idea. So let me help you out in understanding this particular problem statement. This is a personalized food or dish recommender based on a personality, based on the nutrient value available and the personality trend of a person. So when we see this, we know what would be the hardware and software based resources which are available. We need to understand what would be the type of algorithm that we are going to use. This helped me out in finding out the design thinking based approach by organizing or researching the market in available algorithms. The first step was like to find out the different resources, which means the stepwise approach would be like finding the dish involved. The second step would be like what are the ingredients that is involved in the dish. The third step would be like what is the nutrient value that it adds and what are the type of data that is available for understanding all this would be the first step. Then we need to understand what is the type of algorithm that we are supposed to use. One such algorithm is a cognitive recommender system. This employs or this coordinates the personal preference, the personality traits, the behavior of the user, his attitude, combining it with the data, combining with the data driven approach, the public and private data which is available, and with the domain expert knowledge. When I say domain expert knowledge, it is the intelligent knowledge lake that is available. This is found out by means of crowdsourcing, which means the dish review that is available, the way or the restaurants that provides that dish, the review that is being provided to a dish, the nutrient value that it adds, that is available as an intelligence data source. Combining these three data sources, we create a cognitive recommender system, a cognitive based recommender system, which I would suggest you to have a look into it. Like, what do you mean by cognitive recommender system altogether? So, this was one approach that I used using wearing my design thinking hat for creating an AI product. To give or to decide on the framework that we are using on designing an AI product, these are the different uh, CRS based data which is available and the approach that we need to indulge in. The first step would be to look for the big picture, like how would the product would be, visualizing the product, analyzing the alternatives, research the market to find out what is all the existing product that is available and what new feature that you can add or how you can create a new product altogether. Then pick up the most suitable solution based approach. This is the approach where we need to understand about the availability of the data, which I could call it as the theory of constraints, which would be helpful for us to understand the data availability, also with the resource availability and the available algorithm that gives us a most beautiful way of selecting the suitable solution based for our approach. And then the step of iterative process comes into picture, building a prototype, and then test our solution based on the KPI that is being derived out. So deriving KPI is also one important step where we need to measure out what would be the design that we are going to implement. So this approach would help us or would give us a scaled product as well, will optimize our design process, also giving out an economic value to the product altogether. This is also one important step when we are going to create an AI product. This is one of my Medium link where I would suggest to have a look into it. This is ethical AI adoption is in business environment, which speaks about different ethical values when creating an AI product. A non-harming approach in explainability, responsible, non-discriminative, and using contextual integrity or the privacy-based approach that we are taking into consideration when creating any of the AI product. We also need to understand like creating a preventive based AI system. Preventive based is not restricted to health domain. We need to understand a critical AI product when it is being created doesn't constrain ourselves in one particular domain. It needs to be democratized to all domains as well. So I would suggest to have a look into this Medium article. This helps you to understand in the business value that an AI product is going to create with the ethical values involved in it. And this is what is the presentation is all about. I'm just open to your questions. Thank you.
Thank you, Krithika. That was really wonderful. And I hope there's no noise from my side right now. If it is, please do let me know in the chat. And we are open to questions. So if you have any questions or queries for Krithika, do put it in the Q&A box. Okay. I think Krithika, you can stop sharing your screen so that I can share mine. Okay, good. Okay, now it's time for our second speaker, Kristine. She is a freelance data scientist at Upwork, where she works on developing ML algorithm for NLP, object detection, and computer vision. She had completed her bachelor's degree in CS and her MBA as well. And now she is moving ahead with statistics and data analysis. Kristine will describe CNN neural network and transfer learning and how can we do image recognition for many projects. Uh, Please don't forget to put your queries for her. And Kristine, you can take it from here.
Hello, thank you for introduction. Yep. So, good evening, everybody. My name is Kristine, and I'm going to introduce you to the image recognition and in specific convolutional neural networks and where we use it and what are the best cases and how you implement it. So to start, so convolutional neural network, it's a class of deep learning neural networks, and we use it for image recognition, image classification, for NLPs, and even we use for speech recognition in many projects. So when we see, so to start in a simple way, when we see a picture, we see, for example, here we see a dog and we see a picture of a cupcake with chocolate chips. They can be mixed when we see it because our brain is thinking different things. So we take different patterns. We do a guess on it, and we just see the tail, maybe, and the eyes and the nose, and we guess that it's a dog, maybe something else. But for computers, it's not the case, and they don't understand the way we do. So for computers, it's all numbers, and this is the picture how the computer see the image. So we get the image as an input layer, so it breaks it to layers, and we have to start learning the layers, and the deeper we go and more feature learning we do on an image, the better output we will get, because after feature learning we will do the classification and we will understand the image is classifying as a car or an animal or something else. So there are three things to know in this. It's a convolution, which I will talk about now, is a ReLU, the activation function, and a pooling. And then once we are done with this, we have to flatten the picture and get the classification done. So what is the image? So when the computer gets an image, it's for the computer, it's a 3D object. It's three matrices together, and it's a red and a green and a blue. And each of those numbers you see there, those are the pixels, and that's the number of the intensity. So when the numbers are different, we get the mixture of different colors. And so that's how it understands, and it shows the pictures to you back. So we have, once we have the pixels, that's how we have to get these numbers and show the computer and train and understand everything through that. So here is the simple CNN structure we have. We have a picture of the car, and then we divide it into layers, into convolutional kernel layer, into ReLU, and the pooling, and the final is the fully connection layer, which comes out from it. So what is convolutional kernel? So this is a picture of this is the image, and by saying a convolutional kernel, it's like a hidden layer, like a filter, which goes over the initial image, and it's like doing filtering and getting the pixels, and you say the center element, that's the convolutional kernel. Yes, and that's the filter, which is we have to multiply it and then add and get the like it is getting -8 at the output layer is the new pixel value, destination pixel. So the center element of the kernel is placed over the source pixel, and the source pixel is then replaced with a weighted sum of itself and the nearby pixels. Basically, we are breaking the image and trying to understand and learn. So in the case we see slightly different picture what we had, we can still train the machine to understand that that's a dog or that's a car. Okay, so there are three things. This is the convolutional kernel. Then we have the activation function. We have a rectified linear unit. That's the activation function most times we use. Why we use this? Because this allows us to save on the time, and it is not going and activating all the neurons. So what it does, it is converting the negatives into zeros, and it is keeping if it is positive, it is keeping the same value. And in the mathematics, it's just a function of max, 0, and x. So next comes the pooling. So the pooling layer, why we do this? We do this because we want to save in a training time, and we want to avoid the overfitting. So we just take the 2x2 filtering, and we can use a max pool, or we can use an average pool, and we take the image, this dimensions we have, and from there we can make smaller and smaller and smaller. And for example, if you see here, we have 1, 1, and a 5, 6. From there, I will take the max pool, which is 6, the maximum number 6. So I will have 6 from here, and then from the yellow, I will have number 3, from green number 8, and from the blue one number 4. So together I will get totally new one, 2x2, 6, 8, and 3, 4. Yeah, so I could choose average pooling, but in most cases people use max pooling. In average, I have to just put the average numbers in that, if you see. So yes, so after this, so when we have the pooling, all these layers, the hidden layers we do for the learning, you can choose to do yourself, do more deeper. You can just repeat the layers again till you are happy with your architecture. So for the use cases, you can use different data sets. You can do your own projects. And for example, there is a MNIST data set. It's a database of handwritten digits. It's available from the 60,000 examples. And it is the training site, 60,000 and 10,000 of the test cases. And this dataset is a subset of a NIST dataset, if you heard about it. So what people did, so they used the LeanIt 5. This is a type of architecture, CNN architecture. So people already studied, and they did different kind of architectures which are based on CNN, but they are having more layers. For example, LeanIt 5 has 7 layers. And how it's helpful for us. So when we do our projects, we can already go and see what people did and use their architectures, the transfer learning models, and we can change it based on our data set, and we can implement and see the accuracy, and it's working, it's not working, we are happy with it or what, and we can implement it. So you don't have to do yourself everything. You can use whatever is there already done, and you can change it and change according to your data set. So here, the input layer, you see 28 by 28. That's the size of the digit, the image given. And then it's trying to putting 32 filters, and then it's trying to layer by layer, it's filtering and filtering, and then it's getting the flattened features of 2 and the output is coming 1 by 1, 1, 10. So as you see, it's like a learning process of the pic image, and how computer is learning it, and how we are breaking into layers and doing the feature learning. The second example I wanted to give, it was the C410 dataset, which has 60,000 colorful images, and they are all classified in 10 classes, like airplane, automobile, bird, cat, deer, whatever. Yeah, and each class has 66,000 images in it. We have, I think, 50,000 training images and 10,000 in test images. You can do this project yourself and you can use the dataset. Here, for example, I put that for the same project, you can use different transfer learning models like VGG16, ResNet, ResNet50, and etc. And you see the accuracies when you use on your dataset these models, you get different accuracies, and you can choose which one works for you the best, because you might use the VGG, it will work for you, it may not work for me. I had many projects I used, and it was not the best for me, but for somebody else it was working. ImageNet, so just a few examples like about the libraries and projects. The ImageNet project is a large visual database, and you can use it yourself. You get all the, you can use for visual object recognition projects, and it has over the 10 million images, colorful images you can use. It's just an example of the project you can use. So case studies, regarding the transfer learning models, the architectures, the LINET, the first successful application of the convolutional neural networks. It was developed by Jan Likon in 1990s, and the best known is the LINET architecture. It was used for zip codes, to read the zip codes and digits. The next one is the AlexNet. I wanted to talk about. So the AlexNet was mainly popular for the CNN computer vision, and it was developed by 3 people, the Alex Krzyzewski and Ilya Sutskever and Geoff Hinton. The AlexNet was submitted, the ImageNet, for the challenge, and it was very successful at the end. It was common only to have a single convolutional layer previously, and then it added the pool layer eventually. The next one is the GoogleNet I wanted to talk about. It was the winner of the from the Google, Zagati. He was the winner, and he main contribution was the development of the inception module, and it reduced the number of parameters in the network. Next one is the VGGNet. So this was developed by Karen Simonian and Andrew Zisserman. They became known as VGGNet architecture writers, and the main contribution was in showing that the depth of the network is a critical component. So they used 16 layers model, which I used myself, and I was happy to have such thing, and it's very useful. Next comes the ResNet, the residual network developed by Keming He. So these are the examples of the transfer learning models which you can use, and there are of course much more than these mentioned. I will be very happy to connect to all of you if you have any questions and answer to your questions. The time is very less to go in hands-on and show you the projects and how it works in real, but I will be happy in the future to share that as well. And please just send whatever questions you have to my email or to the Slack whenever you feel free. Thank you so much.
Thank you, Kristine. It was really nice. Let me share my screen. Okay, so if you have any questions for both our speakers, you can put it in the chat. And you can also connect with the speakers via email. I'll put a link, or the speakers can themselves put the link into the chat for their email IDs. And yeah, if you have any questions for both the speakers, we are here to answer. Okay, so now like to wrap up the things. You can follow us on our all social media platforms. We are on, I think, all social media platforms, and or you can email us at datascience@WWCode, and you can register for our upcoming events at womenwithcode.com/datascience. We come up with really great events, so do check it out. And thank you so much our speakers, Kristine and Krithikka. You guys were really great today, and I would like to thank our audience for joining in with us today. So yeah, thank you very much. The recording of this will be soon uploaded on our YouTube channel. So thank you guys. Have a great day.